Put it in a bag. I don't want to hear it. Okay, let's solve these equations. Okay, so just like our exponential equations, if we have the exact same logarithm on both sides, what does x have to be equal to right here? 12. All right, this is kind of like a duh. I mean, of course x is 12. That's the only thing that's going to make this equation true right here. Now, the second one, if we've got the log of 2x plus 1 is equal to log base 3 of x, we can't do anything with that algebraically because they have different bases. Okay, they have different bases. So just like with exponentials, if they have different bases, we can't just set them equal to each other. So our option here, our only option for solving this is to use our calculator. And we can solve any equation in our calculator by graphing. And the easiest way to do it is to get it equal to 0. So we just move the log base 3 of x to the left side. So we subtract it to move that. Now, you got to be careful when you type this into the calculator. Okay, the first one's easy because it's just the log of 2x plus 1. But the second part, we have to use change of base to enter that in. So log of x, close the parentheses. Y'all are really bad about closing parentheses. Divided by the log of 3. Okay, what are we looking for when we graph this? What are we looking for when we graph this? Where it crosses the x-axis. Now, I mean, if you put the left side in y1 and the right side in y2, then yes, you would be looking for the intersection. I like to get it equal to 0, and then I'm just looking for where it crosses the x-axis. Now, my calculator's in a really weird zoom right here, so I can barely see right here where it crosses. So I'm going to go zoom standard so I can see a little bit more. Okay, so I can see where it crosses the x-axis. Second trace 0. Okay, left bound, right bound. I got to get down to those negatives. There we go. I press enter. And I can find out that x is approximately 2.259. Okay, x is approximately 2.259. And again, you could, bless you, you could put the left side in y1, the right side in y2, and you're looking for where they intersect. Sometimes you just have to go searching for that. Okay? Why would not be 1? Because you didn't put in that second log that's not change of base right there. That's not how you type that in. You got to type in the log of x divided by the log of 3 to put that in the calculator. Huh? Oh, sorry. Okay, I'm sorry. I forgot to put the subscript. The 3 is supposed to be a subscript on your paper. I'm sorry. The 3 is supposed to be a subscript. I'm sorry. Yes, minus. Okay, I apologize. I printed that apparently before I fixed it. Sorry. Okay, let's look at C. Okay, let's look at C. We've got log base 4 of x squared minus 6 is equal to log base 4 of 10. They have the same base of those logarithms, so we can just set what's inside the logs equal to each other. So x squared minus 6 is equal to 10, and we solve this by adding 6, and 10 plus 6 is 16. Take the square root. What do we have to remember when we take the square root? Plus and minus anytime we take the square root. Now, I told you we can't take the log of a negative number. However, if we plug negative 4 in there, negative 4 squared is positive 16, and 16 minus 6 is 10. We're good. All right, positive 4 squared is 16, 16 minus 6 is 10, so we're okay. So this is what I was saying. You can get a negative answer for x as long as when you plug it back in, what results inside the logarithm is not negative, okay? So we can get negative answers sometimes. Okay, practice with these two problems right here. Make sure that your worksheet looks like the board.